Hello, welcome to your lesson on transforming trigonometric functions. This is part one of two, so make sure to go to video two after this one. In this one, we'll look at translations and reflections. In part two, it will be about dilations. Okay, there is a notes page that goes with this video. It would be helpful when taking notes, so please print that now. Okay, so first step. Have you memorized the basic sine and cosine graphs? We've done some investigating with that. And as you know, sine graph looks like this. Cosine looks identical, but it's basically been shifted over a little bit. There's some details with these that are very important. Let's look at some of those details online. So I have them here. And we have, first of all, the sine graph. So the sine graph, also known as the sine wave, looks like this. Begins at 0, rises up to 1 at 90 degrees, then falls, crosses the axis at 180 degrees, goes below the axis to -1 at 270 degrees, rises back up to 360 degrees, it's back at 0. So it takes that full amount of time, 360 degrees, to do its full wave back to its starting point. Okay, so memorize that one. Let's look at cosine as well. Cosine is very similar. You can see it's just been shifted over. So let's make the sine disappear and look at the cosine. Cosine, unlike sine, begins at 1, but it follows the same path. It goes down, crosses the axis, goes to a low point of -1, rises, passes the axis, up to a high point at 1. So its full cycle also takes 360 degrees. There they are together again. Make sure you memorize those. And make sure you remember the 360 degrees. Okay, let's take a look at some more details here. So, keywords for these. Number one is amplitude. This is the height from the mean value of the function to its maximum or minimum value. The graphs of sine x and cos x both have an amplitude of 1. Let's take a look here. So what it means by mean value is you think about the central line in both of those graphs. So here's a line that goes right in the middle of that graph. And then that distance from that central line to the top of the wave is 1. Or likewise, you could say from the central line to the bottom, also a distance of 1. That's called the amplitude. So make sure you don't confuse that and think the amplitude is 2, because 2 is the full distance from bottom to top. The amplitude is just that half distance. And the period is 360. The period is the horizontal length of one complete cycle. So again, to complete its full journey, a sine wave begins at 0, goes up, down, down, and comes back to 0 here at 360 degrees. So that's one period. Cosine function, the same thing. We do the center line, there's the amplitude of 1, and one full cycle, 360 degrees. That's our period. Okay, so looking at transformations of trigonometric functions, we're going to begin at probably the easiest transformation, which is a reflection. So we know, looking at a quadratic function, so we'll look at all the transformations always with quadratics first, and then move over to the sine and cosine waves. So here we have a parent function. This one is a parent function of x minus 2. As you may remember, that minus 2 there means it's been shifted over 2 here. And typically our parent function would just be x squared, but in this case we have the x minus 2 because when we see the reflection, it's easier to see it when we've shifted the graph. So anyway, here's x minus 2 squared. Then we're applying this rule to it. We're putting a negative inside with the x. Don't forget, when we apply a negative to the x values inside the function like that, it's going to affect the x values, which means the x values will become negative. So that's going to result in a reflection over the y-axis because every x value becomes negative. So this vertex, for example, is at positive 2. It will now be at negative 2. So here is, first of all, that rule applied to this function. If you put a negative x in for this x, that becomes a negative x right there. And that effect is to have this graph here. Again, we've reflected over the y-axis. All the x values, for example, the vertex, and all the other ones have become negative versions of themselves. Now let's look at that in terms of a sine graph. So here's our basic sine wave again, beginning at 0, rising, falling, going into the negative numbers as well. So our parent function, sine x. The rule we're going to apply is that negative x rule. So again, it's affecting the x values. So our child function is going to be this one. That negative x is input into the x here and becomes negative x. And again, when we see a negative x values become negative, therefore reflection over the y-axis. So does that affect the amplitude in the period? Okay, let's take a look. Well, there's the graph. So here's the original. Now imagine this part reflecting this way and this part reflecting this way, and this is what you get. Like that, right? That part that used to be here is now here, and the part that was negative here is now over here. It's been reflected. So there's our reflection. That has had no effect on the amplitude because all we did is flip the graph this way, and it has no effect on the period. It still takes 360 degrees to complete one cycle. All we've done is flipped over the axis. Okay, so now we're going to look at reflection over the x-axis. So now we have a parent graph x squared, so a very basic graph here. There it is. And the rule we're going to apply here is negative f of x. So now notice the negative is outside here, not with the x. It's outside and in front of the entire function. And when we're affecting the entire function, we're affecting the y values. So this essentially means all the y values will become negative versions of themselves. So for example, you have this y value here. It's going to be a negative version. You have this y value here. It's going to be negative. So the reflection, first of all, the rule applied, the negative is applied to the entire function right here, and it's going to look like this. It's been reflected over the x-axis. So that's a recap of reflections we've seen. Now let's look at it in terms of a sinusoidal function. So here's a cosine graph. So that's our parent cosine. We know it's cosine because it begins at 1 here. Okay, now the rule we're going to apply is the negative applied to the entire function. So that's going to create this child, the negative to the entire function. And again, negative to the entire means negative y values. So all these y values will become negative versions. All these negatives will become positive versions. So here is the reflection. There we go. Okay, see that again. This part, which is the upper hill here, let's say, goes down here. And this part that's down here is going to go up here. Let's watch it again. There it is. So we've reflected over the x-axis. Has that changed the amplitude and period? No, it hasn't. Amplitude is the same, period is the same. All we've done is reflected. It's still a graph that has a height of 1 here, and it still completes its full cycle in 360 degrees. Okay, so here's kind of a summary of that. Yeah, summarizes our transformations or reflections there. Okay, let's take a look at transformation number 2, which is a translation. And to begin, we'll look at a horizontal translation. So let's take again, our parent function, this quadratic, and translate it 1 unit left. So we're going to go 1 unit left. If we're going to go left, you may remember, we have to apply this rule. So first of all, when we go left, we're going horizontally, and that means if changing x values. So here, we're going to put plus 1 on the x, because as you may remember, what you do here has the opposite effect on the graph. So if we put plus 1 here, it's actually going to move negative 1. So here's our child function, that x plus 1 has replaced this x. So now we have x plus 1 squared. And that result is this orange graph here. It's moved 1 left. The entire graph has moved 1 unit to the left. Let's try that with a sine function. But before we look at a sine function in particular, I want to come back to this question that popped up in our recent work we've done. Here is a sine graph in red. Here's a cosine graph in blue. And now that we've talked about translations a moment ago, what transformation can be made on y equals sine x in order to create y equals cos x? So how do we turn this red one into this blue one? And as I mentioned before, a cosine graph and sine graph are just shifted versions of one another. So what do you think the answer to this is? Well, let's take a look. To get the cosine x graph, we can take the sine graph and translate it like this. We can say x plus 90. Remember, plus 90 will actually mean minus 90. So imagine you take the sine graph, the red one, and if you remember the top here was at 90 degrees. We don't see 90 here, but this is at 90. If we shift that over, this plus means actually not right, but left. So take that one, move it over 90 to the left. It will end up being right here. And that will work for every point on this graph. If you move this whole graph over 90 degrees to the left, it will become the cosine graph. So there's our answer. Okay, so let's look at that. For sine and cosine graphs, this movement left to right is called a phase shift. So here is our parent graph. Here's a sine graph. We know because it begins at 0. We're going to apply this rule, the one we just talked about, x plus 90. So this is a phase shift, x plus 90, which means we've created this child because into the function we've put x plus 90. So this x is replaced by all of this. So here it is, x plus 90. And now we see positive, which actually means a negative shift along horizontally along the x-axis. So what will be the result? Well, this. We just looked at that. This whole graph moves 90 to the left. So that moves over there. This point goes to 90. This point at 270 is going to be now at 180, and so on. So here it is. It's been shifted. Okay, so everything's been shifted over. And the amplitude of this one and the period are unchanged because the amplitude, we've just shifted it left and right. The amplitude is still 1 and the period is still 360. It's just been moved over. The actual shape of it has not changed. All right, so our last one here is our vertical translation. So let's say we want to move this graph 1 unit up. Here's our parent function. We're going to apply this rule. When we move vertically, we are moving along the y-axis. So we're going to apply changes to the entire function, so the whole function plus 1, and that means we take the whole function, x squared plus 1, and that results in the orange function. So that green one has moved 1 unit up. Okay, so that's a recap of vertical translations. Let's look at that in terms of our sine and cosine graphs. So first we have this graph. Again, this is cosine because it begins at 1 here. And we're going to apply the rule here. Entire function minus 1, so that is going to be a vertical translation, and there's a minus 1 here. So entire function minus 1, cosine x minus 1. This would be very different if those parentheses around the x minus 1, right? So make sure you know that if there's parentheses there, that would be talking about horizontal shifts, right? But this one occurs after the entire function. So what's happening to the graph? Here it is. Let's take a look. Here's the function. Now we see minus 1, so the entire function will shift down 1. So this was at 1 here, will be at 0. This was at 0, will be at negative 1. This was at negative 1, it will be at negative 2. This was at 1, will be at 0. Everything shift down 1. See, look at that. Down 1 like that. So now the graph is here. So what's the amplitude and the period? Well, the amplitude, don't be tricked there, don't be fooled. It's not negative 2. Maybe your mind tells you negative 2. But remember, there's the central line still. The amplitude is unchanged. The whole wave has moved down, but the height of the wave has not changed. So the amplitude is still 1. And the period is still 360. Again, there's been no compression. So that is your first few transformations on trig functions. We've looked at reflections and translations. And don't forget the keywords like amplitude and period and phase shift. So here, just to recap, we have a regular sine graph, and then we have a sine graph plus 1, so the entire graph moves up 1. Vertical translation, up 1 unit. All right, and now we have a sine graph, and we do this. This one now is within there, so it's affecting x, so this can be a horizontal translation left 90 degrees, so that entire graph moved 90 degrees. You can see from there it moved over here. Okay, that's the recap of those two. Please move on to video 2 after this. It's going to take you into the tougher transformations and in some ways the more important ones for what we're doing here. See you in video number 2.